This is a revision slide for Learning Outcome 1 Software Development Summary. And the first thing we'll talk about is the software development model, or the waterfall model. And the 7 stages can be remembered using a mnemonic, something similar to a dance in the dark every Monday. So it's analysis, design, implementation, testing, documentation, evaluation, and maintenance. And we go through each of the stages and say who's involved in each one of these stages and sort of key things to remember from each stage. So in the analysis stage, you've got your client, project manager, and system analyst all involved, and you should know some of the responsibilities for each of those. What is generated at the end of the analysis stage is a requirement specification, and that's the legally binding contract between the client and the software development company. And most of the analysis document is generated through who, what, when, why, and where, or who, what, where, why, and when questions, the answers to which should be documented by the system analyst in the requirement specification. There are other ways of gathering information as a system analyst: through interview, through survey, through questionnaire, through observation and reading up on the existing document, or reading project documentation, and through expert knowledge. In the design stage, the requirement specification feeds into and inspires the functional specification and the system specification. So the functional spec is what it does, the system spec is what hardware it needs to be able to run. And the client and the system analyst are usually involved at this stage, because the client has to OK things like the HCI design, and really has to be sort of referred to each stage to make sure that the team are happy. The client is happy with what the team are doing. So the system analyst basically works out how to solve the problem at this stage. They've been given the go-ahead, they've signed the contract, and they're off. And they're looking at 3 main areas: looking at the human-computer interface, or the user interface, or the GUI, how the client is going to interact with the program. They're going to think about the data structure, so what variables are used to store the information that the client wants to store in the program. And then they're going to think about the design, so the program design, so how the logic works. And one way of doing that is using pseudocode, another is using structure charts. But I find that pseudocode, because it's linear and numeric, it's very easy to refine, and much easier to refine than a structure chart. But you've got that alternative option. And remember, the analysis stage never went into how to solve a problem. It's only at the design stage that you start to think about solving the client's problem. And then move on to implementation, and this is where usually the system analyst stops having an input, and they give their functional spec and their system spec and the requirement spec to the programmer, and the programmer is responsible for creating source code, some of the test data, or the outline test data, and the final executable, which will be passed to the client for testing and the independent testing group. A fairly simple stage. Usually not so much time is spent on the implementation as the analysis and design, so maybe about a third of the time that it would be spent on the earlier 2 stages. Of course, any problems at this stage could be passed back using iteration, and that's where feedback is given to the system analyst or the project manager, and they look at the design stage, or they go back up again to the analysis stage, and they try and resolve any problems before it costs too much. Moving on to testing, and this is where most of the problems are identified. And because programmers can't reliably test their own code, because they know what works and what doesn't, so they're less likely to test it exhaustively. And that's a key thing to remember here. So usually software development companies hire an independent testing group to basically try and break the software in a methodical and exhaustive way. And they can do it in 2 sort of scenarios. Independent testing group are usually involved in alpha testing, and that is where the software is installed in isolation to an extent, and it can be tested to make sure that it's functionally correct. So, for example, you can pass in normal test data, the limits, so the extreme test data, the limits of some ranges, and exceptional test data, which has no, which is supposed to break the program, or supposed to not be accepted by the program. And what they're looking for is they're looking to make sure that the program is robust and reliable. Robust in that it doesn't crash when they type in something that shouldn't be accepted, and reliable in that if it types in anything and a particular thing happens, that particular thing should continue to happen every time that data is entered in the future. If it passes alpha testing, then it is released to the client, or maybe a selected group of users for the client, and beta testing takes place. And this is where the software is installed on the machines in the office and has to deal with possible conflicts from other software like Skype or Instant Messenger or even just Outlook or Word, and different versions of operating systems and different updates to software packages. And usually the clients get to test it in parallel with their existing system, so it's double the work for them for a couple of weeks, and then they pass back any problems or concerns or successes to the software development company, and the independent test group pull together a sort of survey, a sort of final summary of the test data, and they pass that back or to the implementation team to resolve, or they pass it on to the implementation stage. And at this point, the system analyst, the programmer, and the independent testing group, and maybe even the project manager, are all involved in creating a cache of documentation which would help future members of the software development team, or members of the software development team in the future. And these would be things like making sure the requirement spec is complete, this functional spec and the system spec tie into it, and the source code is fully commented, that the test data is listed, and then the alpha and beta testing results is all sort of combined into maybe one document or one folder. That's the system side. That's to make sure that the software is maintainable in the future. On the client side, and at this point the client would probably be involved in giving feedback as it's developed, the software development company would create a user guide and a technical guide, and usually the system analyst would do this because they are the best at communicating with the client. So they would create a user guide, which is a step-by-step guide to using the program. Probably going to have a lot of screenshots in it, and it will teach the users how to take advantage of the functionality of the program. The technical guide, on the other hand, is less likely to have screenshots in it because it's far more technical. It assumes a lot of computing knowledge, and it's more to do with things like how to install the program, how to resolve any errors, what the error messages mean, and it might have a frequently asked questions section. So it's far more to do with how resolving problems without having to resort to phoning up the software development company. So it's a fairly important stage, this one, because it's where the material is created for maintenance and also for the sort of final shift of the software to the client. So the installation, and that installation will be done by the system analyst. Once the software is installed, it's got to be evaluated. So after a period of time, the client, the project manager, and the system analyst get together and they have a meeting, and it usually sort of boils down to, is the software fit for purpose? So I've given you some questions to think about to make sure your software is fit for purpose. Is it robust? Okay, so can it handle unexpected data? Is it reliable? Does it do the same thing with the same data every time? Is it portable? Can it be easily transferred from one system to another? for example, PC to Apple, or could it be just transferred from one version of Windows to another, or one version of Visual Basic even? Is it efficient? So does it use the resources efficiently? Is it usable? It's a key thing to remember. If the client cannot use the software, then it is not fit for purpose. So it's got to be usable. So there's got to be adequate online help or a user guide. The support has got to be there, and the icons have got to allow the users to identify what each function is. Yeah, it's got to be a nice experience using the software. And finally, is it maintainable? So can the software be updated if something changes in the future? So that's a fairly lengthy conversation, and it will probably decide if the software development company are hired in the future. Last stage in the waterfall model is the maintenance stage, and there's three main types. There's corrective maintenance, that's where you resolve bugs which weren't either identified or resolved in the testing stage. If this type of maintenance is necessary, then the software development company have to pay for the time, because they should have ironed out those bugs before it was delivered to the client. Happens about 17% of the time usually. Adaptive maintenance is the second type. Now this is where the client perhaps upgrades their machines, and this means that the software doesn't work correctly. So it may be a minor change. It only happens about 18% of the time. For example, a new operating system upgrade, or new backup system, or something like that. But because it's a new system and it wasn't part of the original specification, the client has to pay for this. The third and the most popular, about 65% of the time, it's perfective maintenance. It's very visual. It's usually sort of changing the look of the software rather than the functionality, although sometimes it will be adding in features that the client thinks would be useful at a later date. And because it's adding to the software or adapting its visual appearance, the client pays, because it's the software itself is fit for purpose and is relatively free of errors. So the software development company don't have to pay for that. And each maintenance patch, doesn't matter how small it is, requires a full software development cycle. So that's back through the analysis, design, implementation, testing, documentation, evaluation, and maintenance.